So for my topic, I decided that I wanted to talk about the different types of database management systems and kind of how we got to the point of deciding between relational and non-relational. So upon some research, I found that we obviously began storing data using paper and file systems, and we'd had punch cards that held information. But in once the development of computers started to come around, we started doing flat file databasing, which was kind of the first way that we did databasing on any sort of computer or server device. And flat file databasing was essentially where we stored everything in just one table. And we would just keep adding data into this one table. We just keep adding rows and rows and rows every time we needed to have a new data set, which meant that we had a lot of redundancy, and it wasn't as easy to just call and to query things. It was a whole process, and companies didn't really rely on it as their sole databasing system. It was something that they only really called on if they needed it, if there was some sort of emergency, or if it was like a last resort. But once we started realizing that there was all this redundancy, we realized that we can do something with more relationships. So that kind of began the idea of a relational database. And it started with hierarchical databasing, which is just one-to-one relationships where you had the root parent, you had your root parent object, whatever, and then that then splintered out into parents and children and so on and so forth until eventually you would get to a file somewhere within those folders. But again, that meant that it was a one-to-one relationship. So, for example, if you had an employee who maybe had multiple people he had to report back to, this way of databasing had no way of really showing that in an easy way. You would have to have redundancy again. So we moved on to what we now call relational databasing systems, which is a one-to-many relationship, saying that one employee can have multiple bosses, just like one order form or one customer can have several orders that they place, or one user can have multiple accounts, or they could have, in the scope of our SQL class, they could have multiple vehicles, or a vehicle could have multiple wheels, and so on and so forth. So relational databasing is what we've been working with mostly. So we've been working with SQL, and now we've been introduced to Mongo, which is a NoSQL. But so with the relational databasing, it allowed us to connect tables without the redundancy. So it was saying that one table could be pulling information from multiple other tables to create one other main source of data that you could access everything that you needed to through different key pairings. This was generally used in analytics, but as applications started to began to develop and became more modern, and there was a bunch of different, it wasn't just plain data that we were storing. The structure kind of started to fall apart because we needed to start scaling, and we needed to start accepting data types that were out of the norm, such as images or video files or audio files. So from there, we began doing NoSQL databasing, which allowed for multiple data types, different kinds of information, and it still held relationships, but you could have, in this example, it talks about Facebook, how a user's friends, people who liked it, and the author of comment were all types of Facebook users. Just like user posts and friends activities were all types of like things that you could do on Facebook that a user could perform, but they weren't necessarily the user. And then likes and comments were a functionality that extended directly to Facebook, but it was always from the specific user's posts. So Um, in this, it became clear that we needed to have a new way of kind of structuring our data. So, different types of NoSQL databases are document databases, graph stores, key value stores, and wide column stores. Since we have been working in Mongo, it seems like Mongo is a document database where things are stored in key value pairs, but it can contain a single document can contain a bunch of different key value pairs or key array pairs or nested documents. And the benefits are for sure the scalable and performance. They don't take up as much, they don't require as much work from your computer as a relational database would require. You can do constant data pushing and constant data pulling, and you don't have to worry about it using up your usage or slowing down your machine. It also incorporates object-oriented, so it makes it super, super flexible. And since it's not being done in the conventional relational database way where everything is restricted to certain data types, you can then expand from there. But so a direct comparison between the two, with a relational database, it's harder again to include rich data types. It kind of it slows down the whole development process, and it also can't scale. So relational databases, again, the larger you get, the longer it's going to take for your queries to run, and obviously time is money. So when relational databases came out, they started incorporating different data types, and they started providing different features, which allowed larger content-rich type databases. Scaling is built into it, so you can make your database bigger as your company gets bigger, and since your teams are more productive and you don't have to spend as much money on hardware since it's not taking up as much space, it's cost effective.